All right, hello once again, Jeff Scott of Rankin Technical College, coming to you with probably another fairly short video. And these videos I'm doing are based on the AWD, or Application and Website Development 1100 C# programming class. And in particular, I'm doing some work on the textbook we're using for the class, that being Murachs C# 8th edition. And I'm up to chapter 16 of 25, of 22, I should say. How to organize, document, and test your classes. So this is basically saying when you're all done, how to basically make sure. But it's even more than that, I guess, because it's probably something you should look at first. So how to organize classes, how to document them, how to create and use class libraries, and how to implement unit testing. And unit testing is very small in here. You could make a whole class just on unit testing. But as far as organizing your classes, C# is a little different than some other programming languages. You can put two public class files, one after the other, in the same class. Now, for example, in Java, you can have a class within a class, but only one can be public, and then inside of that, you can have one or more private ones. But in C#, it's one of the few I know of that allow you to do that. You can also have a file with a nested class, more like the Java that I just mentioned, where here's the class and then there's another one inside of it. So as it says, when two classes are closely related or when each is very small, it sometimes makes sense to code them in the same file. That way the project consists of fewer files. Now, in principle, I don't disagree with that. In practice, I don't do that. I always, no matter how small the class, put each class in its own file. All right? But that's me. I'm not saying there's anything wrong with doing that. Kind of the reverse of this is you can take a class and you can split it across multiple files. That way what you have are basically what are referred to as partial classes. And you would do that for the opposite reason. If the class got too big, you may decide that you want to put it in two different files. To do that, as it says, you just code the partial keyword before the class keyword to indicate that the members of the class may or may not be split across multiple files. So as it says, if the class you're working on becomes very large, or if you want to have different programmers work on different parts of the class, all right, using partial classes would make a lot of sense. Visual Studio uses partial classes to separate code that's generated from a form class from the code that's entered by the programmer. You may or may not have noticed that. C# also lets you code partial methods within partial classes. All right. And it says they're typically used by developers with that really have a lot more experience, and they're not covered anymore in this text. So there's a class that's split into two files, again, with partial and with partial. All right. Namespaces, you may or may not have noticed, but virtually everything we've done all semester. So if I bring up just the one we were working on and I bring this up, you'll notice when I bring up the code, come on, come on. When I bring up the code for this, it's part of a namespace. And the namespace virtually, almost always, is going to be exactly the same as the name of the project folder. Now mine's different, but remember I manually went in and changed this up here. All right, here's that partial class. So there's the form stuff. Okay, all right. Every C class that you create must belong to a namespace. When you create a C# app, Visual Studio creates a namespace that has the same name, again, as your project does. You can nest namespaces. It says, in fact, most of the .NET namespaces are nested. For example, system.collections.generic is actually a namespace named generic that's inside of the collection that's inside of system. Although all of the classes of a project are typically stored in the same namespace, there's nothing that says that has to be the case, especially as projects get more and more complex. All right, you'll find that that's probably not going to be the case. Also, if you want to share a class among several projects in a class library that we'll talk about in just a bit. All right. Next, they show you file scoped namespaces. As it says, they're very new, introduced in C# 10.0. When you use a file scope namespace, you end the namespace declaration with a semicolon and not a pair of curly braces. All right. So the rules for file scope namespaces: each file can declare only one file scope namespace. Only using directives can precede the declaration of a file scope namespace, and a file cannot declare both a file scope namespace and a block scope namespace. All right. Documenting classes. There's a couple of ways that you can do this. You can add XML documentation. You may or may not know this, but if you add three forward slashes, remember 2 is a single line comment from the rest of the line over to the right, and it's green. Normally, when you put in 3 slashes like this, that allows you to create what's called XML, or extensible markup language documentation. And there's certain tags you can use. Notice there's a summary tag, there's a returns tag, a param tag. Some of them, I believe, are listed in here. Could be wrong. I thought they were. No, maybe they're not. Okay, but they are listed here. Oh, here they are. So summary, value, returns, and param. What it does is it provides even more internal project documentation. Some people will tell you, because I've heard this before, that they're a waste of time. Now, if this is your first class, you'll probably hear me talk about XML again more than once. We'll talk about it in the AWD 1000 class as well. But the thing is, in the early to mid 1990s, people decided that HTML, the hypertext markup language, had kind of outlived its usefulness, and they were going to come up with a new language called XML, extensible markup language, where you could create your own tags. It caught on, but not really the way people thought it would. All right. But in this case, we're using it, and we're using it to provide more internal in-program documentation than we'd have otherwise. So again, how you can view it, and with screen tips in the code editor. And the last thing I believe that's in here is how to create and use class libraries. We will create at least one project, and probably more, that have a class library. Now think about a regular library. Okay, now you go to a library, you take out a book, you use it for a certain amount of time, and then you return it. That's not really the key component of a library, though. The key component of a library is that the library has resources that can be shared amongst multiple people. And that's the way that a class library works. So for instance, if I created a class, and in that class I put in a bunch of methods that I use all the time. Maybe I wanted to make my own array class where I did a whole bunch of stuff that I did with arrays. What I could put that into a class library and then bring it in to any project I'd be working with. So as they mentioned here, so far the classes you've seen have been created as part of a Windows Forms project. If you want to be able to use the classes you create in 2 or more projects, you can store them in a library. That's the simplest definition I can think of. A class library consists of a collection of related classes. When you use a class library, you can use any of them without copying them into your project. So your project will remain smaller in size. It says classes that are created in a Windows Form project must be included in every project that uses them. By contrast, classes that are in a class library are separate from any project, so you can use them only when you want to use them. One benefit, as it mentions here, of using a class library is the size of each project is then reduced. Another benefit is it simplifies maintenance. If you do have to go in and change something, you change it all in one place. The main benefit is it allows you to create reusable code. And really, anytime most managers hear reusable code, cha-ching, cha-ching, they're thinking of saving some money. So they've got pictures. You don't really learn anything from these pictures. We will, again, create one or more projects that have a class library in there, and I think then they'll make sense to you. So they do have this library project where they create it, and then they add it, a reference to it, and then use it in a project. All right? And the last thing that's discussed in the chapter is something that's called unit testing. Really, they have not talked a lot about testing in this book. Yes, they have had a chapter that's on debugging, but they really haven't talked about testing per se very much in this book. So it says, so far you've learned how to test a project by entering both valid and invalid data to make sure it works the way it's supposed to. This is fine for simple apps, but as it mentions here, it becomes more difficult as your apps become larger and more complex. Instead of testing them manually, then, what you'd really rather do, if at all possible, is you would rather have a bunch of tests that you created in advance and use unit testing. So that's what this last section of the chapter is about. As they say, it provides a way of testing individual methods to verify they work as expected. You code one or more of these methods that are called unit tests for each method that you're testing. All right, now some of you may have heard my little story about this already, but when I got my first programming job many years ago, all right, one of the first projects that I worked on, this was back in the olden days, sorry, back when you picked up a telephone, it was on a wall, all right, usually, and you picked it up and you got dial tone, all right. And one of the first projects I did was I had to add some functionality. So, for instance, if you dropped the phone, you wouldn't lose the dial tone, stuff like that. Why am I telling you this? Because what I had to do was ended up writing about, I don't know, 5 to 10,000 lines of code that I was putting into a system that had 5 million lines of code in it already. So I had to make sure that not only did my stuff work, but that I didn't break what was already there. So what I had to do was for every new routine that I wrote, I had to write a test for it. I had to tell what the test would do, how the test would be run, what the expected output would be, and what to do if something unexpected happened. Then I had to, and literally that document, and I'm not exaggerating, was about 500 pages long. Then I had to have what was called the design unit test review, where I had people who had code that interfaced with my new code come in and tell me what was good and what was bad about this. All right, and it's a very much a changing experience. And what I mean is, some of the stuff I did, they did, I was new, no excuse. I probably could have done it better. People, at least with some of the stuff, and they were like, you could have done this much better. You did this in a very poor way. Except, well, it was a way for me to learn too. All right. Some of the advantages of using unit tests, as it says, it helps you identify problems earlier in the development cycle. The earlier that you find a problem, the cheaper it is to fix it. Another advantage is that once you develop the unit tests, you can run them anytime you make a change to the code. All right. There's also something that's called TDD, which is test-driven development. All right. I don't think they talk about that in here. They might. I don't remember. But with TDD, what happens is you write your tests first. So every test you write will fail because you haven't written the code yet. But you write the test first. You write how to handle it if it succeeds. You write how to handle it if it fails. Then you go back and write the code. And then you run the test to see indeed if it fails, did it fail the way it was supposed to be? If it succeeds, did it succeed the way that it was supposed to? And many people are very in favor, they're very much proponents of using test-driven development. All right, so again, help you find problems earlier. You can, each time you make changes, you can run your tests again, and you don't have to every time you make changes, you don't have to run the app and retest it. Just test what's changed. All right. Makes debugging easier because when a test fails, you only need to debug the most recent changes. All right. So as it says, unit test provides a way to write code that automatically tests individual methods or units. You can unit test any class, business classes, database classes, form classes, anything you need to. You code unit tests within a separate project. By default, as it says, Visual Studio provides for creating 3 types of test projects. That is MS Test, XUnit, and NUnit. I actually did a little bit of work with XUnit in the AWD 1115 class that you took 4th semester. And here they talk about MS Test. So they create a separate test unit project, show you how to add it. I'm not going to do this. And how to code unit tests. Typically, you use that with asserts. All right. And with an assert, basically what the assert is going to do is it's going to run and do one thing basically if you have an assert if it's expected, and another assert if something happens that's not expected. All right. And I think that's pretty much it. That's it. So again, we will go through much more of this later on. The next section has only 2 chapters in it. Chapter 17 is on file input output, and it talks a lot about the 2 basic file types, those being text files and binary files. Finally, chapter 18 is kind of a prelude into the last section of the book because it is on LINQ, which is line item query, or line integrated query, depending on the book you write, or you read rather. And we will look at that and look at how to write what are known as some basic LINQ queries. So when I come back in just a bit, we'll go over chapter 17, how to work with file I/O. I'll see you then.